Good morning to all of you. In previous session, we have seen direct form 1 and direct form 2 realizations of discrete time IR systems. We have obtained those direct form 1 and direct form 2 realizations by using the difference equation or by using the system function. Today we'll be discussing one more realization structure, which is called as cascade form realization. So we'll try to realize the given IR system by using cascade form realization. So here we have been provided with the transfer function or the system function h of z. Okay, so we have to obtain the cascade realization for the given system function. Okay, so the given transfer function, in this case it is capital H of z is equals to 2 in bracket z plus 1 whole upon z in bracket z minus 0.1, in another bracket is z plus 0.5, in third bracket it is z plus 0.4, right? So again, for realization purpose we'll need negative powers of z in this case, so we'll try to multiply uh, the z to the power minus 4 in numerator and denominator, so that we should obtain the given system function or transfer function in the required form. Okay, so multiplying the transfer function numerator and denominator by z to the power minus 4. Okay, so we obtain standard form as given by this h of z. So if I'm multiplying z to the power minus 4, z to the power minus 4 in numerator and denominator, so 1 z inverse I will send inside the bracket. Okay, so what will remain? So out of this z to the power minus 4, I'll be sending 1 z inverse inside the bracket, so the remaining 2 will be as it is. This z to the power minus 3 will be as it is. Z inverse multiplied by z will be 1, plus here it will be z inverse, so I'll get 1 plus z inverse, right? Similarly in denominator, uh, as there are 4 z's here, right, so therefore we are multiplying it with z to the power minus 4 in numerator and denominator, right? So 1 z inverse will be utilized to eliminate this z, so z inverse multiplied by z will be 1. Okay, another z inverse I will send inside bracket, so z multiplied by z inverse will be 1. So here it will be, so another z inverse I am multiplying with this first bracket, so z inverse multiplied by z will be 1, so it will be 1 minus 0.1, z inverse will be there, right? Next, second z inverse I will multiply it with the second bracket, so it will be 1 plus 0.5 z inverse, and the remaining last z inverse I will multiply it with this third bracket, so it will be 1 plus 0.4 z inverse. Okay, right? So we have multiplied z raised to power minus 4 in numerator as well as denominator, right? So out of 4 z to the power minus 4, that is 4 z inverse, we have utilized 1 z inverse inside this bracket, so we get 1 plus z inverse. Remaining 3 z inverse we have kept outside, while the in denominator we are utilize the z inverse for each one of these terms, right? So first z inverse multiplied by z will be uh, z z inverse multiplied by z will be 1. Another z inverse will be multiplied with this first bracket. The third z inverse will be multiplied with the second bracket, and this fourth z inverse will be multiplied with this third bracket. So we'll get this term. For cascade realization, we require terms in multiplication. For parallel realization, we'll require terms in addition form, right? So here these terms are already in multiplication form, so we'll just separate it out. Okay, so we'll represent this h of z as, so we'll make it as h of z is equals to, so we'll simply adjust this terms. So I will take this to z to the power minus 3 as the first term in multiplication, right? Second, I will take this 1 plus z inverse upon 1 minus zero point 0.1 z inverse. Okay, so let 1 plus z inverse in numerator whole upon 1 minus zero point 0.1 z inverse. Okay, so 1 minus zero point 0.1 z inverse will be there. Okay, third term I will take it as 1 upon 1 plus zero point 0.5 z inverse. So 1 upon 1 plus zero point 0.5 z inverse will be there, and this third term will be 1 upon 1 plus zero point 0.4 z inverse. 1 plus zero point 0.4 z inverse will be there, right? So the same equation is there, simply I have rearranged these terms, or I have written these terms as a separate multiplication terms. Okay, because for cascade realization we'll need these terms in the system function in multiplication form, right? So it is very simple to draw the cascade realization. So the cascade realization for the given system is shown in following figure, right? So here again in input you can indicate it as x of n or x of z. So how you will draw this cascade relation as, first it is multiplied with the constant 2, so I'll be using a constant multiplier with 2, followed by there are 3 delay elements, so I'll indicate it as z inverse first delay, then followed by the second delay, then followed by the third delay. Okay, so here I will get 2 multiplied by z to the power minus 3, right? The next, here numerator and denominator terms are there, right? So this can be realized by using direct form 1 or direct form 2 realization that were discussed in the previous session. So for realization of this term we can use direct form 1 or direct form 2 realization. So here we'll use direct form 2 realization, so that will require only one delay element, right? So how it can be done, so one adder will be required. Here we'll be using one delay element z inverse. Okay, so we'll be feeding back this output into the system, so we are realizing this denominator. So denominator, in the denominator we have this 0.1, okay, minus 0.1, so we'll be using, instead of minus 0.1, that coefficient will be simply 0.1, that will be added here, fed back here, then it will be added in this term. Okay, and similarly this numerator will be realized. So here this, for this numerator we have for this numerator will be simply then simply this numerator have the coefficient 1, right? So here you have 1 and that will be added here. Okay, so here we have obtained the direct form 2 realization, or you can also draw the direct form 1 realization for this term. So in that case, this particular structure will be drawn on left hand side here, and this structure will be drawn on right hand side. So there will be two delay elements. Okay, one delay element will be used at the input side and one delay element will be at the output side. Okay, so there will be two delay elements, but here we are drawn it by using direct form 2 realization. Similarly, this third term will be drawn, right? So here again I'll be using a feedback loop, right? So here I will need a delay element, then it will be feedback into system. It is plus 0.5, so it will be minus 0.5, and then it will be added here, right? Similarly, this last term. Okay, so again one adder I'll be needing. Then in again feedback I have this z inverse, right? Then it is multiplied with this constant coefficient 0.4. So as it is in denominator, I will be taking it as negative, right? It will be fed back, and this will be here indicated as the output of the system. So y of n or capital Y of z. Okay, so this is how we have realized this equation. Initially this term, that is 2z to the power minus 3, has been realized. So 2 were realized by using constant multiplier, then z to the power minus 3 by using 3 delay elements. Then this term in numerator and denominator is realized by using direct form 2 realization. Okay, so denominator here indicated in this feedback loop, right? That is z inverse multiplied by minus 0.1, that will be added here with 1, right? Then similarly 1 plus this particular z inverse, okay, that is 1 z inverse will be added here. Similarly, this next term is indicated by using this feedback loop here, that is here it is nothing but your 1 value, okay, which is added, which is here feedback into this loop, that is plus 0.5 z inverse is there, right? Similarly here again this 1 plus this z inverse multiplied by 0.4 will be added here, and that will be the final output. So this figure indicates the cascade form realization of the given system. Okay, so this is how you will be obtaining the cascade realization, right? So system function has been given. If system function has not been given, then you will be obtaining system function by using its input output equation. You can take the z transform of the given input output equation to get h of z. Okay, and then after obtaining the system function, you will rearrange it in term so that you will get the negative powers, as well as you will represent these terms in multiplication form, and by using these multiplication terms you can obtain the cascade form realization. So in next session we'll be discussing the parallel realization of the IIR systems. Okay, so thank you for joining this session.